Hello, everyone. Welcome to another Trimble webinar. This week is an exciting webinar where Trimble and Amberg will be presenting together about tunnel surveying and a really recent collaboration between the two. So today with me, I have Elzbieta. Maybe you can introduce yourself.
Hello, everyone. Thanks. My name is Elzbieta Prokopova. I work for Amberg Technologies. We are based in Switzerland. We have offices close to Zurich, but we have actually partners all over the world. And I'm product manager in the tunnel department.
Perfect. Well, thank you. Thank you for joining today. And Elzbieta will be doing the majority of the presenting today with an exciting demonstration. So looking forward to that. For those of you who don't know me, my name is Riley Smith. I work for Trimble as a marketing manager in our tunneling and monitoring business areas, and I am based in Colorado in the US. So just before we get started, everyone, if you are having any technical troubles, if you can't see the presentation or you can't hear us, please type that into the chat window and let us know as soon as possible, and we'll try to get that resolved. At the same time, if you have any questions for either of us as we're going through the material, also put those in the chat window, and we'll answer those as we go, and we'll save some time at the end of the webinar to answer any questions that we haven't. So with that, so today what we're going to start with is we're going to talk about Trimble tunneling and what our mission and what we offer is through the Trimble side of things, and then we'll get into Amberg Technologies and their history in tunneling, which is long and quite a great history. And then we'll get into more on what Trimble and Amberg are bringing to the tunnel surveying industry. And we'll talk about the applications and workflows involved in that. And then Elzbieta will take us through a great live demonstration of the Amberg software using Trimble Total Station. And at the end of the presentation, we have some next steps, or if you want to find out more information or you want to get started trying out any of the software or any of the features that you see today, we'll give you some information on what to do next and of course save some time for questions. So with that, we'll kick it off. So introducing the Trimble tunneling business. So we really focus on that core technologies that Trimble is known for, the positioning, whether that's total stations, optical, laser scanning, or GNSS, and combining that with unique workflows for the tunneling projects. And it's really all about trying to be as productive as you can be on a tunnel project. As those of you who are familiar and work in that industry, you know that there's the faster you can get work done in the most accurate way, the better. And we really do that by focusing on the entire life cycle throughout a tunnel project, whether it's from the start, where we're talking more about geodetics, setting up the control network, doing site preparation, all the way through the construction phases, whether that's general construction purposes, whether that's convergence monitoring, reporting deliverables, all the way through to when a tunnel is finished, and we're looking at more inspection and maintenance operations. All right, I'll let Elzbieta speak to this.
Okay, so I will quickly introduce Amberg Technologies. So Amberg Technologies are part of Amberg Group. And Amberg Technologies has 4 units. One unit is a rail unit that is focusing on surveying on the tracks. Then we have a tunneling unit focusing on the measurements in the tunnel. Then we have a seismic unit focusing on the geology prediction to find out what kind of geology we can expect next 100 meters in front of the tunnel face. And the 4th unit are the services. So we are providing geodetic services mostly in Switzerland and surrounding countries. But today we will focus on a tunneling unit, as we are talking about tunneling, of course. This is also the oldest unit from Amberg Technologies. So this year we are celebrating 40 years anniversary of our unit. This is the time since Mr. Amberg, who founded the company, decided that he needs to measure profiles and get the results in the real time, and created the first profiler with the real-time data processing. So today, many years later, we still measure profiles, but hopefully we do it a bit faster, and the computer to process it is much smaller.
Excellent. So with that, we want to introduce what we'll be primarily talking about today, which is a combination of the Amberg tunneling software with Trimble robotic total stations. So I'll play this video here and let you all watch this.
Mm.
Perfect. So I hope that came through. Everyone could see that all right. If not, the great thing about that is you can watch that at any time. If you go to trimble.com/Amberg, you can watch that video again in case the audio or if it didn't come through, or if you didn't, if the streaming wasn't quite fast enough. So that is available. So right now, what we're going to do is I'm going to switch over, give presentation to Elzbieta. So with that, while we're switching here, and just want to say, so what we'll be talking about today is that combination of the Amberg field and office software with Trimble robotic total stations and data collectors. And what we'll go through here is a live demonstration of that, and talk about some of the workflows and the unique applications that can be used for.
Thank you, Rayleigh, for the introduction, and I will jump right into the topic. So what we will be basically talking about then also in more details, and what we will see in the live video, is the whole workflow that every tunnel surveyor has to do. Part of it, let's say, in the beginning of the tunnel construction, but most of it basically daily in the tunnel construction. So the first step there is always how to prepare the data. So we get some design, axis, profile, alignment. We have to measure the fixed points, and we have to bring all this to the software to basically create our model of the tunnel. Then we define what we want to measure in the field, and then all this we will send to the field, to the navigator tablet. There we connect with the Trimble total station, and we will carry out all the tasks that are necessary to do on the daily basis in the tunnel. So that's always first thing, is to position the total station, and then we have several tasks to check the excavation, for example, measure profiles, but also to stake out points and navigate drill rigs, for example. all the results are shown in the real time. So this is really the big benefit, that we see the results directly and we don't have to go back to the office and process the data and come back. When we are done with the measurement, we will send the data back to the office and generate reports out of that. So firstly, PDF that we typically have to print and sign, and then the others like DXF exports, overbreak, underbreak, volume calculations, and so on. So that will be basically the whole workflow we will cover today. So when we start in the office with the office software, so Amberg Tunnel is name of the office software, and it's really software which is created by tunnel surveyors for tunnel surveyors. So all the workflows, all the functionality is optimized for tunneling. This is really one big difference compared to the other softwares that are, let's say, more generic surveying softwares, but this is really a software focused on tunneling, which also helps us to have more efficient workflow and to deliver the results how the customer needs them in a shorter time. So what we always need first is to define the tunnel. So the first step is always the alignment. We can import it from XML, text, or grammar format, or if as surveyors, as sometimes happens to the surveyors, if we got our data only in PDF, we can of course type them in the editor directly. The next thing to define are theoretical profiles, typically several theoretical profiles or several construction stages. So all that we can again import or create manually, depends what kind of definition we got. Then using theoretical sections, we define on which stationing, which profiles are valid, and with this we create a 3D model of the tunnel, which is also great visualization or a great check that the design that we imported is correct. Of course, we do this for each construction stage. We can also copy the design between construction stages to make the work easier. And then we need to define the tasks that are saying what we want to do in the tunnel. So this would be an example of pipe umbrella definition in Amberg tunnel. In the live demo, we will see in a minute, we will use just a few basic tasks. But here I would like to mention that there are over 30 tasks for Navigator. Basically, for every task that surveyor has to do in the tunnel, we have a specified task on Navigator. So you can really pick your workflow and use the task that fits your workflow the best. We can start from the excavation, from staking out the drill pattern, checking the profiles, then checking the shotcrete, staking out support and arches, staking out formwork in the end, and many others. So for everything, you will basically find a task to fit your need. So with that, I would switch to the live demo, because showing the slides is not so interesting, and I think that it's always much more fun to see what's really happening in the software. So now we see Amberg Tunnel software. This is the starting screen. I already have my project defined. So here I have already my whole construction site with several tunnels and also shafts. And part of this construction site is, so in one of those tunnels is hidden my office, and we will today see the demo only on the kind of fake tunnel in the office, because the tunnels typically don't have such a good internet connection. So here now we will look at the project tree, and we will see exactly the things that I was talking about in the same order as we need to enter them. So it's all really, the workflow is really, if you go line by line, this is what you need to do. So starting from the axis, so from the alignment, we have here in the editor defined horizontal alignment and vertical alignment that gives us the axis in 3D. Then as the next step in the design, we have the theoretical profiles. So this one is the theoretical profile of my tunnel. At this point, maybe I could show. So I have just my tunnel on the wall. Unfortunately, not a real tunnel, but here we will have a Trimble total station and this kind of small tunnel that we can use for this demo. So this is the profile of the tunnel we currently have, smaller than the normal tunnel, but otherwise normal tunnel heading. And here in the theoretical sections, we have the 3D definition of the tunnel. So using the theoretical profile, we have here defined our tunnel in 3D. We can visually check that everything is fine. So this is for the definition of the tunnel. As the next step, of course.
Hey, I'll put a question for you. For the design for the tunnel, can you import designs from other software like a CAD or a LandXML file into Tunnel Office?
Yes, we can export XML. So basically, we need axis in the LandXML. So that one we can import. From the DXF, we can import profiles. So not really a whole 3D model of the tunnel directly, but if we get the profile, then we will basically extrude it along the axis. Of course, we can also interpolate from one profile to another. So typically, if there are more profiles, we will basically construct the same 3D model.
Perfect. Awesome. Thank you.
Thank you for that question. That was a good one. I skipped that information. So now I continue to the control point. We will need them to position the total station in the tunnel. Also here I can check in 3D where my control points are. So that's also a good check that the coordinate system is the same like the axis and so on. So basically with this, I have finished the whole, let's say, theoretical preparations. And the last thing to do before we go to the tunnel is to define the tasks. So for each construction stage, I can define the tasks. So the things that I want to do or I want to measure in this construction stage. I already have some tasks here, but I will define newly the ones that we will need. So I will just create a task. And the one which is, I would say, the most basic, but also one of the most useful tasks is point check. I will just give it a number to have it in order, but you can call it whatever you want, basically. So I will call that check excavation. Also, for example, if you want your tunnel crew to measure something on Monday, you can call this task measure Monday morning, and then they know exactly when to use the task.
So these tasks are what will be sent to the field software so the crews know what the job is for the day.
Exactly. Basically, the whole brain of the operation is in the office. When you will see how the navigator tablet is operated, you don't need a fully trained surveyor to do at least some basic tasks. So then you can, for example, cover profile measurements if you explain tunnel crew just how to level the total station. Basically, the rest is very easy. I will create here one more task to measure profiles. So I will check here profile measurement. So that will be the second task that we will do today. Here I have a bit more settings available, so I can basically choose which profiles or on which stationing and how many points I want to measure. So my tunnel heading is, or my tunnel face is somewhere around heading 512, so I will define one profile there. And this my profile is really small, so I will say I want to measure the points on the profile every 10 centimeters. In tunnel of the normal size, it will be rather every meter or every half meter, but it again depends on the definition of your project. So I have my points defined here, and maybe I would say that I do not really measure the floor of the tunnel because, yeah, that's not really so interesting to document. So I can also delete those points. Maybe I still want to have 1 point here on the side. Now I'm quite happy with this. So I can hit the save button. If my tunnel is longer and I want to measure more profiles, I can just duplicate this profile and copy it to the interval. So let's say from stationing 513 until 520, every meter I would like to measure the same profile, I can just easily copy them over and have my profile every meter. So this is basically how the tasks are defined. I will show here one more task which I already have here prepared, and this is take out of the blast points. So here the tunnel that is in my office is done with new Austrian method. So this is now the blast pattern for the next blasting in one part. So we will then also try how to stake out the points easily with Navigator.
And I noticed at the top that you can look at those patterns in side, top, and 3D view as well.
Yes, yes. Thank you for that. Of course, I can. So my pattern is defined yeah, here. So I can also see the blast pattern from side, from the top, and also in 3D, as you said. So my favorite way how to look at the 3D is to go along the axis.
Oh, cool. So it's like you're kind of driving along the axis of the tunnel.
Exactly. And then you can just move and see what is in there. So now I have this blast pattern actually defined for my complete tunnel, but I could also add more patterns for different stationing. So for example, if I know that my geology is changing, I can also have a blast pattern for my geology type A, B, C. So I could just have 3 tasks, and in each task I could have the geology or the blast pattern predefined for different geology. And then if somebody in the tunnel tells me, oh, now we have a worse geology, we have to switch the blast pattern, I have all the data with me.
Cool. There's a question that came in from William asking, can you rename the point numbers once you've created them? I think that's in regards to like the profile measurements in the blast points.
Yeah, that's actually a very good question. Thank you for that. Yes, you can. You can just, well, basically all these editors work a bit like an Excel sheet. So I can just rename this point to 32 and the number is changed. For the profiles, it has a bit more meaning because for the profiles, the points are measured in the order I define them. So now we will start from this point going to the right. For example, if I want to, sorry, now I added the point instead of clicking on it. I will remove this one again. So, but if I want to start from this point and measure anti-clockwise, I can do that using this renumbering icon, saying I want to start from this point and measure anti-clockwise, and all the points are renumbered. So I can do it one by one, or for the profiles, this is actually the easier way how to do that.
Awesome, very cool.
Okay, so now I will store my settings, close all the windows I have opened, and we are ready to go to the tunnel. So I will export the whole project to Navigator. What is important to mention here is that the whole project gets exported. So all the tunnels, all the tubes, all the construction stages, all the tasks, everything is there. So I don't have to worry, for example, if there are some crosscuts and so on, if suddenly somebody in tunnel will tell me, now we need you to measure the profile in the crosscut. I have all the data with me, so I am always on the safe side. So the
while that's exporting, I did have another question. When you're defining the control points, can those be imported from somewhere else?
Yeah, thanks for that question. Of course, we have a flexible text import. So basically, you can import whatever text file or a CSV file. So basically, you just define in Amberg tunnel software in which column is which information, and then you can import all your points, of course.
Mm-hmm. Cool.
Okay, so now we have the whole project exported, and we will go to a Navigator tablet. Just to mention, the export can be done. So typically I would export the data to my USB memory and then use it for the import. It's also possible to send data via cloud. Of course, for that you need internet connection in the tunnel or somewhere nearby. So the USB possibility is still quite popular. On the Navigator, I can have several users. So each user who is using the tablet can have his own login. So then I can track who was doing the measurement. And everybody, of course, have a password. So in this case, I am the administrator. So I will log in as an admin. One difference is that the basic user doesn't have the settings. So as an administrator, I still can change some settings. But if you give the tablet to the, let's say, a worker who has no surveying knowledge, maybe you don't want them to change any of the settings you gave. So in such a case, normal user cannot change your settings. So in the administration area, I will load the project. This was the last one I did. So loading project succeeds, so everything is fine. So I will go back from the administration. Also in the administration is all the connection with the instrument settings and so on, but you basically do this once, and then the total station and the tablet are paired like with any other Trimble collector, so you don't have to care about that anymore. Now, as I said, we have the whole project as we had it in the office with us in the tablet. So I will select the heading where I'm going to work. And yeah, my is the poster heading tunnel. So this is the poster I have on the wall. But I could, in this way, easily switch to any other construction site, any other tunnel I have in the project. So now when we look here, so basically we have the total station looking roughly at our tunnel face. So I will zoom a bit on our tunnel. And the first thing to do is always to position the total station. So I will start with the biggest button. So that's quite intuitive to position the total station. Always next to the task, we have also the image telling us what this task will happen. So in case
we can't see Navigator if you're showing that right now.
Sorry, thank you.
No problem. There you go.
Is it better now?
Okay. Yep.
Okay, good. I will go one step back so you see how I got here. Okay, yeah, so this was the menu where we were, and we will start with the instrument position, the biggest, most visible button, so we will start with that. Yeah, here, as I said, the image telling me what the task will do. So I can have here more options how to position the total station, but mine is standing on the tripod, so I select the tripod and press the play button to start the positioning process. So here you already see that it's not really something that you needed to study surveying for several years to manage this, and it's really not getting more difficult along the way. So it tells me, look, if your instrument is leveled. If it's not, it doesn't let me continue. So I really have to level the instrument. Mine is already leveled, so it lets me continue. Now it says, measure the first point. So I have my control points here also on the poster where you can see them. I hope you see the laser dot.
Yeah, the bottom center.
Yeah, perfect. Yes. So this is one of my control points. In this case, I don't have prisms, so I have to really target the points somehow accurately. If I have prisms on my control points, of course, the total station will center to the prism automatically. So then I just need to aim somewhere close to the prism, and the total station will take care of the rest. So I will measure point number 2. Also, the graphics is telling me what to do. So I need to measure the third point. Again, this can be changed in the user settings. So if I insist on more than 3 points being measured, I can also force users to do that. But now I just measured the third point, and the software tells me that total station is positioned. So as you see, I didn't have to enter the control points numbers, so it took them automatically from the project, compared it with the database of the points, and figured out which points were measured. Here it's just telling me.
Sorry to interrupt you. Is it performing a resection, or is that
Yes.
what it's doing right now? Yeah.
Exactly. Yes, it's performing resection. Yes. If it cannot find a unique solution, then I would get a choice of the options which control points are measured. But here from the project, it's clear. So from the geometrical constellation of the points, it's clear which one I measured. So I got only one option. And now it's telling me just to make sure on which heading stationing my total station is. So this is something that you typically know in the Talon roughly on which heading stationing you are. So I know that this is roughly correct. So my total station is positioned well. So we can start with the real measurement. So the first task we will do, so we defined our tasks in the excavation construction stage. And here are all the tasks that were also available in the software. So you can see that I have really the whole project with me. Again, the pictures are telling me what the task is going to do. So we will start with the basic one just to check the excavation. So it's really when the excavation is finished, the rocks are cleaned, and you can go there and you should just, for example, quickly check if they don't have underbreak anywhere. So for that, the fastest thing you can do is basically I started tracking measurement, and now I can move the red laser around, and basically every spot which is somehow suspicious, I think maybe this is inside of the profile, I get immediate feedback and I can check the points. Also, if I want to, I can store the points for the documentation. It would be later on visible in the software as a measured profile. But it's really the fastest way how to check if your excavation is roughly correct. So I can just move the red laser around, measure all the points I want. But
so
for sure,
if it's red,
go ahead.
I'm just watching here. If it's red, if the dot is red, that means it's under break, and if it's green, it's over break.
Yes, exactly. So underbreak is always wrong. So underbreak is always red. A little bit of overbreak, this is again the settings we could change in the office, is green. And I think that over 10 centimeters of overbreak, I already have in the settings that this is too much. So it's also telling me in the colors, you can set those limits according to limits of your project or according to the specifications of your project. So always the color dot is telling me, is it good, is it bad? And then I can also see the deviation from the theoretical profile below that. I can also see on which heading stationing I am, and also in the left bottom corner, I can see distance from the axis, so the local coordinates basically, in case I need it for something. So this is really a very basic task which already gives me a lot of information. But if I want to measure profile, so let's say I somehow checked the excavation and everything is fine. So now let's measure the profiles for the documentation. So I do not want to do that point by point because yeah, that's really no fun. So we will use the automatic profile measurement. So we define the profiles in the office. So now we will just tell from which stationing to which stationing we actually want to measure the profiles. So I just point the red laser somewhere and say I want to measure my profiles from stationing 512. Now I pick the point a bit on the side on the wall of the office to get actually different stationing. And here is a small message telling me that there is one profile in this range. So this is the profile I defined in the office earlier. So that's fine. This is the one I want to measure. So I will start the measurement, and I have to press the start button to start it. And now you will see the red laser going over the profile. So here, as my tunnel face is quite flat in this case, or my tunnel profile, it's much easier for the total station to measure the profiles. In the real tunnel, it would be iterating, so it would be searching the points on the correct profile to really get the right result. Ouch. Now something went wrong.
Tunnel's not big enough.
Maybe I did something wrong with the definition. Yeah, well, tunnel is not big enough. That's for sure one of the problems, but I think it started to measure the points just fine. So let's give it one more try.
While it's measuring again, there was a question that came in. William asked about the resection or the instrument setup. So the software is taking those measurements, and then it's doing a best fit to find which of those points match the geometry that you've measured. So it automatically does that. That is the question. And then the second part of the question is it also storing the setup information for the instrument? So like the resection residuals and like where the instrument was located when you perform that resection?
Yeah, thank you for the question. Yeah, that's a good question. Yeah, it's exactly, it's storing the geometry, or it's, sorry, now I think I said the task wrong. So okay, we will just have an ugly profile in the office. I think I left the tolerance there too big, so I think that the tolerance is 20 centimeters or so, and yeah, then it doesn't really have to make the effort on the poster. But to answer your question, yes, it's what it does. It's comparing the geometrical position of the points, let's say in the local system, and in the global system where we have the control points defined, and it's doing Helmer's transformation from one to another. It is storing the results. There is a log file where each result or each position of the total station is stored, including all the accuracy. So you can always get this data back if you need to investigate what happened.
Perfect.
Also, what is there? There is, again, a setting, so you can give user a maximum sigmas he has to fit in, otherwise it won't be accepted. So you can also make sure that nobody will do orientation of the total station, for example, with worse accuracy, that's 1 centimeter and I don't know, a second in angle or something like that. So this can be defined by the user in the office or by the surveyor, let's say. Was that the complete question, or was there one part
Yeah,
I missed?
I think you answered it all.
Okay, super. So we will move to the last task we have for today, and those are the blast points. So now I measure roughly on which stationing my tunnel faces. In case I have more blast patterns defined, based on this, the software will pick the correct one. And now I can just easily click on each point, and the total station will find it. Again, if the surface is more rough, it will iterate. Now it doesn't really have to make so much effort to find a point. So basically then I would just going through the points, marking them on the tunnel face. I can also click directly on the screen, or I can just keep pressing the next button and marking one by one. Also, there is a possibility as a documentation I can store where I stake out the point. Just if somebody asks later, I can say this is where the point was marked.
Okay.
So it's good to be always on the safe side.
So that little save button always stores the point or the measurement.
Exactly, exactly. Basically, the tasks like profile measurement that already by default are meant for the documentation are storing the data without pressing any button. The tasks that are meant more for the stakeout, so here the main goal of the task is take the point. So if you want to save it as well, there is the save button to store the point.
And another question that I think is relevant to this from William again. Thanks for all the questions, William. If you fail a reflectorless reading, so if it for whatever reason can't take the measurement, does it skip the point or does it continue to measure, or is there some kind of setting that tells it when it should stop measuring and move to the next one?
Yeah, good questions. All very good questions. Thanks for that. There is a setting. So I can set the setting in the office. If I am admin on the tablet, I can also change the settings in the field. So I can set the stakeout tolerance, and I can also set the number of trials. So basically, if it will fail to find a point, it will try 5 times with this current setting, and then it will just give up and go to the next point. The same goes for the profile measurement.
Awesome.
And I think that actually the stakeout tolerance is where I made a mistake with the profile measurement, because I left here the stakeout tolerance. Oh no, 3 centimeters, so that's not that bad. But I think that, yeah, I didn't force it to really find the points close enough. Shall I try the profile measurement once more?
Yeah, if you'd like to, we have plenty of time.
Okay, then let's go for that. I will make here my limits a bit smaller, so the total station need to make some real effort. And start the task once more. I will again tell the heading stationing interval where it should measure the profiles. And hopefully it works this time. So basically here for the speed of the profile measurement is also quite a big difference. Oh, no, something is wrong. But there is a quite big difference in the speed of the measurement if the total station has the scanning option or not. So with the scanning option is much faster because it's iterating through all the points on the profile and it doesn't really make one point after another. So we also see that only after all the points are finished, they are shown on the screen. So that really speeds up. So now it's picked first 2 points. Really not sure why it didn't work this time. But I have some another data examples that I can show in the office, so we will see the results anyhow. So with this, I would transfer back from the tunnel to the office, where we will see how to process the data we measured. So first, or on our way from the office, we export the data again to the USB stick or send them via cloud if internet connection is available. But I can tell you that the USB stick option is used in 99% of the cases currently.
Is there any options in Navigator to do like a basic report or just an overview of that information? Like if I wanted to see for a specific profile what the underbreak and overbreak points were, can you do that?
Yeah, well, we basically see that directly after the measurement. So we always see, yes, the profile wasn't measured really nicely. I didn't show it really well, but when the profile measurement is finished, I can click on the measured points and I see directly the overbreak and underbreak values there. So also with the red laser, I can stake out the point. So also if there is, for example, some point with the underbreak over on the profile, I can directly mark it with the red laser and show people where is the underbreak, where is the place that should be fixed.
Okay, perfect.
So it's giving me direct feedback, and then all the reporting, all the documentation is done in the office. So from here, I just switch back to the office and import data from Navigator. It's all packed in one file, so it's easy to import. And I can also see here a list of what was measured. So I see that in the excavation construction stage, I measured 4 profiles. 3 were when I tried it with the profile measurement. 1 is stored that I did with the point check measurement. If I, for example, had scans or also profiles in some other construction stage, it would be shown here as well. And now this is really the part of the software I like, because now I imported the data, and as the next step, I can directly go to the analysis where the results are. And now I want to analyze or export the results of measured versus design. So I can just go here. Well, these profiles I measured today are not really nice, so I will use one of the older ones, which were measured earlier today. So I can directly grab this and print it to PDF. So literally a few seconds after coming back from the tunnel, I have the report ready.
Can you export so you can print them as PDF? Can you export them in other formats or to like a CAD file or something like that?
Yeah, sure. That's a great question. There are several other formats how to import it. I will show them, yeah, in a minute. So here I have the basic report. Basically, I see what was measured. I also see heading stationing. I can have here a logo of my company. I see the volume. So basically, I have all the information I would typically need to report in this page. So that would be something that people typically really print and give to their bosses or someone. Of course, there are some other or many other options what can be exported. I will show that maybe in the presentation because that's a bit faster than exporting it one by one. It's not so much fun to watch it. So the first one is, of course, the graphical report I showed. The second one is the volume calculation. So overbreak, underbreak, volume of the material, if we are talking about layer thickness, for example. So I can get all that also in a form of of a DXF, or I can also export all the information that are on the reports in a text file. So I can basically get Excel sheet with all the calculations that were done in the software, just in case I want to do any other calculation or process it in any other way. And then the next one is, of course, a CAD format, so we can export DXF. It's possible to export it in 2D and also in 3D. So depending how you want to process it further, you can pick what kind of export you like. And the last thing, which is again useful if you have a BIM, you can export a 3D model of the measured data in OBJ file and then import it to some other 3D software to further evaluate it. One more.
Yeah, there
Are
was
there
a
questions?
question. There was a question that came in from. I can answer this one, I think, but Leo asked, does Amberg Navigator run on my Trimble tablet or on other controllers, or do I need a specific one? So the answer, Leo, is it runs on any of the Windows-based Trimble data collectors. So the TSC7, T10, or T100 would all are all compatible with the Amberg Navigator field software.
Yes, thanks for that question. I will quickly jump back to the software and show one more thing. I mentioned that we can also report volume of the applied material or volume of the material. So this is mainly useful when you have, for example, when you apply a shotcrete and you want to calculate how much material was there if you are paid by cubic meter. Also, you can use profiling or scanning to calculate volume of the shotcrete thickness. And you can get also this information directly in the field on the navigator with similar graphics as we see here. And then the volumes are calculated in the office. So that would be one more useful feature I wanted to mention there. And then I will jump back to the presentation. And we are getting closer to the end. So as a bit of the overview, so the key capabilities we have seen mostly today. So one is the guidance and stake out of the points, easy to use and intuitive in the field. As built and excavation control, so point check, profile measurement, all the documentation can be easily measured and then documented in the office. There are also more guidance tasks. For example, when you need to drill pipe umbrella, we can also navigate directly the machine to the right place and angle. Shotcrete control analysis, so this is the last one we have seen. we can use profile measurement or laser scanning to check and document the shotcrete thickness. Again, big advantage are the results in the real time when directly after spraying, a few minutes after, we can check the result before the machine goes away and then document everything in the office. Last two I didn't mention so far, but I will quickly jump onto the topic of convergence monitoring and also some scanning capabilities of the software. So the Amberg tunnel has also a module for convergence monitoring. So basically to measure the convergence points and report them. There is also a task in Navigator to make this workflow easier. And then again, all the data are loaded back to the office and we are getting the reports directly out of the measurements. So here we see an overview where we have the profile view, and here it will be better visible. So in the profile view, we can see how each point is moving. We can also exaggerate this more so it's better visible. Now it's again a small profile and just a small movement. And we can also see the movement in time. So we can see the movement in the settlement, traverse, and longitudinal direction. And always we can see how it developed in time. Also with the colors, we can set some boundaries. So for example, when we are here in the yellow, or there can be also red color, it's telling me that it's over the limit more than was expected. I have to do something there. So this is also a functionality that we can find in the software. And last but not least, we have also a scanning module. So today we did not scan, but I would just quickly jump to, so this is a profile analysis. I wanted to show a scan analysis. So there are also many functionality how to process and screen scan data, again specialized on the tunnel. And we can see a 2D view and 3D view. The colors are encoding the distance of the point cloud from the theoretical design. It's probably better visible in 3D view. So here we see the color from with different colors. And if I turn on here the 3D model of the tunnel, I can see that all these yellow and pink color are under brake. Of course, the color scale can be user defined, so this is just how I have it now, but all the blue ones are over brake, and here I can see I have a problem again in a very intuitive way.
Great.
So with this, I would jump back to the presentation. So we are basically on the end. So this is what I wanted to present from Amberg tunnel capabilities. Now, if you want to take over, Ailey, this was, I think, partially answered already in the previous question.
Yeah, so we only have one or so minute left, so we'll just finish up the rest of the material here. There's not much left to go, and then there's some questions that came in, and we'll answer those. So just to wrap up on kind of next steps and clarifying some important points. So we were talking about the Navigator software, and this question was already asked by Leo, so thank you for that, Leo. But to reiterate, the Amberg Navigator field software is compatible with the Trimble Windows-based data collectors like the TSC7 and T100. And right now, Amberg Navigator supports S-Series Trimble robotic total stations. So the recommended model is the S7. The reason being, as Elzbieta mentioned in the presentation, is the S7 has the scanning option enabled, which vastly speeds up the profiling measurements compared to non-scanning enabled instruments. So a lot of speed there in terms of measurements in the DR mode. Right, and in terms of packaging, so depending on what you need or how the crews are split up on the project. Some crews might be dedicated to doing profiling, some might be doing convergence monitoring. You can package the Amberg software really in the way that you need it for your crews. You can also get everything in one whole bundle if need be. These are kind of four of the primary packages for some of the major tasks, especially what we were showing today. So, for instance, if you're doing both as-builting and staking out of blast patterns and rock bolts and so forth, there's a profile plus guidance package, and then you can split those out if you need those individually. You can do that, and as well for convergence monitoring, there's a module for that. And additionally, there's many others which we really didn't have time to get into today, and maybe we can do that in a future webinar. All right, so last slide here for everyone. Next steps. So what I suggest, anyone who wants to find out more information, of course, this webinar was recorded, so you'll all receive an email with that recording link. Feel free to share it with any of your colleagues. If you would like to start testing out the Amberg field and office software, I suggest you reach out to your local friendly Trimble distributor, and they can help you get more information. If you want to just do your own research and find some information, both on the Amberg and Trimble websites, you can find more information there. And as well, that same video we showed, as well as some technical notes that go more into the applications and the workflows. So all of that is available. So with that, I know we're about 2 minutes over time, but I think there were some good questions that came in. So let's answer those, and then we'll end the webinar. So if anyone does have other questions, feel free to type them in now. So I'll just take a look. So there was three or four or so questions that were all the same, so I'll try to answer those right now. So thank you all for all of you asking about SX10, SX12 support with the Amberg software. So right now, the Amberg Navigator supports Trimble S series robotic total stations, not the SX series. If you are using the SX10, SX12, and you're using scanning, especially, you can import that data into Amberg Tunnel Office. I'm not sure exactly off the top of my head what formats are supported. Elsbeth, maybe you can speak to that, but for scanning, I think the major formats like LAS are supported.
Exactly, we support the basic format, so PTS, LAS, E57. So basically, if you are using those instruments, you just need to position the data in the field or in Trimble software, and then load this data to Amberg Tunnel in one of these exchange formats, and then you can do the processing in exactly the same way.
Perfect. And that would apply to any laser scanner. So if you're using an X7 or a TX8 laser scanner, you could also get the data from that into Tunnel Office. So let's see, any other questions that popped up? Klaus is asking this. I guess this is more a question for you, Els, but feel free to answer this if you want. So the question from Klaus is there a web version of Amberg Tunnel planned?
That's actually a very good question. So we are going towards, let's say, a web environment. We already have a software for tunnel inspection in cloud environment. Currently, what you can do is that you can have a project stored in the cloud and use it as a remote project. So you don't have to have your project locally, but you can have project on the cloud, and more people can work on this project in the same time. This is as far as we got so far, but I believe that in the future we will move in this direction, but let's say not this year.
Perfect. Thank you for the questions, everyone. It doesn't look like any more have popped up. So thank you, everyone, for your time. A huge thank you to Elspetsa for that great demonstration and going over the workflows in the Amberg software. I don't think this will be the last time we'll have Elspetsa on a webinar. I'm sure that we'll have another one in the future.
Well, thanks for organizing the webinar and having me. I always struggle like what to push into such a short webinar. So I'm also sorry for the overtime, because I think that the good software you can only recognize in the detail. So when you start to really use it and test it, and you really have to solve your problems with it. So I would really encourage people to get the demo and yeah, get the hands on the software.
Yes, I agree with you there, definitely. So everyone, this will be recorded, so you'll receive a link today, tomorrow sometime with that link of the recording. And as Elspeth mentioned, if you do want to find out more, please reach out to your Trimble distributor and get you going from there. But thanks everyone, thanks Elspeth, and take care, and hopefully see you on another webinar again soon.
Oh, thank you. I hope to see you soon as well.
Take care, everyone.